Welcome back. So we've covered a fair bit of ground, and just to let you know, I took a little break after going through all of these, and I'd just like to show you how I get back to where I'm at, because if we tried to just write X here and press Shift and Enter, because our Colab was disconnected, it's now connecting, because as soon as you press any button in Colab, it's going to reconnect. It's going to try to connect, initialize, and then X is probably not going to be stored in memory anymore. So there we go, name X is not defined. That's because the Colab state gets reset if you take a break for a couple of hours. This is to ensure Google can keep providing resources for free, and it deletes everything to ensure that there's no compute resources that are being wasted. So to get back to here, I'm just going to go restart and run all. You don't necessarily have to restart the notebook. You could also go, do we have run all? Yeah, we could do run before, that'll run every cell before this. We could run after, we could run the selection, which is this cell here. I'm going to click run all, which is just going to go through every single cell that we've coded above and run them all. However, it will also stop at the errors where I've left in on purpose. So remember when we ran into a shape error? Well, because this error, we didn't fix it, I left it there on purpose so that we could keep seeing a shape error. It's going to stop at this cell. So we're going to have to run every cell after the error cell. So see how it's going to run these now. They run fine, and then we get right back to where we were, which was X. So that's just a little tidbit of how I get back into coding. Let's now cover reshaping, stacking, squeezing, and unsqueezing. You might be thinking, squeezing and unsqueezing? What are you talking about, Daniel? Well, it's all to do with tensors. And you're like, are we going to squeeze our tensors, give them a hug? Are we going to let them go by unsqueezing them? Well, let's quickly define what these are. So reshaping, as we saw before, one of the most common errors in machine learning and deep learning is shape mismatches with matrices because they have to satisfy certain rules. So reshape reshapes an input tensor to a defined shape. Now, we're just defining these things in words right now, but we're going to see it in code in just a minute. There's also view, which is return a view of an input tensor of certain shape, but keep the same memory as the original tensor. So we'll see what view is in a second. Reshaping and view are quite similar, but a view always shares the same memory as the original tensor. It just shows you the same tensor, but from a different perspective, a different shape. And then we have stacking, which is combine multiple tensors on top of each other. This is a V stack for vertical stack, or side by side, H stack. Let's see what different types of torch stacks there are. Again, this is how I research different things. If I wanted to learn something new, I would search torch something, stack, concatenate a sequence of tensors along a new dimension. Okay, so maybe not H stack or V stack, we can just define what dimension we'd like to combine them on. I wonder if there is a torch V stack. Torch V stack, oh, there is. And is there a torch H stack for horizontal stack? There is a H stack, beautiful. So we'll focus on just the plain stack. If you want to have a look at V stack, it'll be quite similar to what we're going to do with stack, and same with H stack. Again, this is just words for now. We're going to see the code in a minute. So there's also squeeze, which removes all one dimensions. I'm going to put one in code. Dimensions from a tensor. We'll see what that looks like. And then there's unsqueeze, which adds a one dimension to a target tensor. And then finally, there's permute, which is return a view of the input with dimensions permuted, so swapped, in a certain way. So a fair few methods here, but essentially the crust of all of these, the main point of all of these is to manipulate our tensors in some way to change their shape or change their dimension. Because again, one of the number one issues in machine learning and deep learning is tensor shape issues. So let's start off by creating a tensor. and have a look at each of these. Let's create a tensor, and then we're going to just import torch. We don't have to, but this will just enable us to run the notebook directly from this cell if we wanted to, instead of having to run everything above here. So let's create another X, torch dot a range, because range is deprecated. I'm just going to add a few code cells here so that I can scroll, and that's in the middle of the screen there. Beautiful. So let's just make it between 1 and 10, nice and simple, and then let's have a look at X and X dot shape. What does this give us? Okay, beautiful. So we've got the numbers from 1 to 9. Our tensor is of shape torch size 9. Let's start with reshape. So how about we add an extra dimension? So then we have X reshaped equals X dot reshape. Now, a key thing to keep in mind about the reshape is that the dimensions have to be compatible with the original dimensions. So if we're going to change the shape of our original tensor with a reshape, and we try to change it into the shape 1, 7, does that work with the number 9? Well, let's find out, hey? Let's check out X reshaped, and then we'll look at X reshaped dot shape. What's this going to do? Oh, why do we get an error there? Well, it's telling us here, this is what PyTorch is actually really good at, is giving us errors for what's going wrong. We have 1, 7 is invalid for input size of 9. Well, why is that? Well, we're trying to squeeze 9 elements into a tensor of 1 times 7 into 7 elements. But if we change this to 9, what do we get? Ah, so do you notice what just happened here? We just added a single dimension. See the single square bracket with the extra shape here? What if we wanted to add 2? Can we do that? No, we can't. Why is that? Well, because 2, 9 is invalid for input size 9, because 2 times 9 is what? 18. So we're trying to double the amount of elements without having double the amount of elements. So if we change this back to 1, what happens if we change these around? 9, 1. What does this do? Oh, a little bit different there. So now instead of adding 1 on the first dimension, or the 0th dimension, because Python is 0 indexed, we added it on the first dimension, which is giving us a square bracket here. If we go back, so we add it to the outside here because we've put the 1 there. And then if we wanted to add it on the inside, we put the 1 on the outside there. So then we've got the torch size 9, 1. Now let's try change the view. Change the view. So just to reiterate, the reshape has to be compatible with the original size. So how about we change this to 1 to 10? So we have a size of 10, and then we can go 5, 2. What happens there? Oh, it's compatible because 5 times 2 equals 10. And then what's another way we could do this? How about we make it up to 12? So we've got 12 elements, and then we can go 3, 4. My code cell's taking a little while to run here. Then we'll go back to 9, just so we've got the original there. Oops, they're going to be incompatible. Oh, so this is another thing. This is good. We're getting some errors on the fly here. Sometimes you'll get save failed with Google Colab and automatic saving failed. What you can do to fix this is just either keep coding, keep running some cells, and Colab will fix itself in the background, or restart the notebook, close it, and open again. So we've got size 9, or size 8, sorry, incompatible. But this is good. You're seeing the errors that come up on the fly, rather than me sort of just telling you what the errors are. You're seeing them as they come up for me. I'm trying to live code this, and this is what's going to happen when you start to use Google Colab and subsequently other forms of Jupyter notebooks. But now let's get into the view. So we can go z equals, let's change the view of x. View, we'll change it to 1, 9. And then we'll go z, and then z dot shape. Ah, we get the same thing here. So view is quite similar to reshape. Remember though, that a view shares the memory with the original tensor. So z is just a different view of x. So z shares the same memory as what x does. So let's exemplify this. So changing z changes x, because a view of a tensor shares the same memory as the original input. So let's just change z. We'll change the first element by using indexing here. So we're targeting 1. We'll set this to equal 5, and then we'll see what z and x equal. Yeah, so see, we've got z, the first one here. We changed the first element, the 0th element, to 5. And the same thing happens with x. We changed the first element of z. So because z is a view of x, the first element of x changes as well. But let's keep going. How about we stack some tensors on top of each other? And we'll see what the stack function does in Torch. So stack tensors on top of each other. And I'll just see if I press Command S to save, maybe we'll get this fixed. Or maybe it just will fix itself. Oh, notebook is saved. Unless you've made some extensive changes that you're worried about losing, you could just download this notebook, so file, download, and upload it to Colab. But usually if you click yes, it sort of resolves itself. Yeah, there we go, all changes saved. So that's beautiful, troubleshooting on the fly, I like that. So x stacked, let's stack some tensors together, equals torch stack. Let's go x, 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 because if we look at what the docstring of stack is, will we get this in Colab, or we just go to the documentations? Yeah. So list, it takes a list of tensors and concatenates a sequence of tensors along a new dimension, and we define the dimension. The dimension by default is 0. That's a little bit hard to read for me. So tensors dim equals 0. If we come into here, the default dimension is 0. Let's see what happens when we play around with the dimension here. So we've got 4 x's, and the first one, we'll just do it by default, x stacked. Okay, wonderful. So they're stacked vertically. Let's see what happens if we change this to 1. Ah, they're rearranged a little and stacked like that. What happens if we change it to 2? Does it have a dimension 2? Oh, we can't do that. Well, that's because the original shape of x is incompatible with using dimension 2. So the only real way to get used to what happens here by stacking them on top of each other is to play around with the different values for the dimension. So dim 0, dim 1, they look a little bit different there. Now they're on top of each other. And so the first 0th index is now the 0th tensor, and then same with 2 being there, 3, and so on, but we'll leave it at the default. Then there's also V stack and H stack. I'll leave that to you to practice those, but I think from memory V stack is using dimension equals 0, or H stack is like using dimension equals 1. I may have those back to front. You can correct me if I'm wrong there. Now let's move on. We're going to now have a look at squeeze and unsqueeze. So actually, I'm going to get you to practice this. So see if you can look up torch squeeze and torch unsqueeze and see if you can try them out. We've created a tensor here. We've used reshape and view, and we've used stack. The usage of squeeze and unsqueeze is quite similar. So give that a go, and to prevent this video from getting too long, we'll do them together in the next video.